for everybody. So, but we'll go ahead and get started. Thank you all so much for joining this community show on survivorship and deciding the golden truth. I'm joined today by Saurabh Agarwal, one of our senior product managers. And Saurabh, can you go to the next page, please? Housekeeping, generally, we record all of these sessions and post them to community. Please keep yourselves on mute unless you have a question. If you do have a question, please raise your hand first to ask, or you can ask questions in the chat and we'll get back to them, or we'll get to them as soon as the Q&A happens. And otherwise, just enjoy. Please take just a quick look at our safe harbor slide, and we can move on to our agenda. So I'll go ahead and forward to the next slide.
Yeah, sure.
Great.
Hey everyone, this is Saurabh, and I'm a senior product manager at Reltio. I have been with Reltio for a few years now, I think 4 years approximately, and I look after some of the core features like a survivorship, data unification, core APIs, DB, LCA, cleanse, and a few more. And what the topic that we are planning to cover today is like one of the most basic or the core features of any MDM service, which is called survivorship. And to understand what survivorship is, let's look at this problem first. Okay, so assume that you have a lot of systems in your organization. Any company would have a lot of systems. Let's take bank for an example. Within a bank, for you might be a bank's customer in multiple ways. You might have a credit card, an account, savings account, a current account, maybe also a loan. And for each of those products that you use from the bank itself might have separate databases to maintain all the customer records. So you might have a record in their credit card database. You might also have a record in their loan database, in their savings account database. And all of these data, the same person data that resides in the databases, they might be different based on when you applied for the loan or the credit card, right? So it can happen that a person's phone number in the different systems within the same organization, in this case a bank, may be different. And when somebody from the same marketing team wants to connect with that customer, they do not know which phone number to use. So this is the scenario where three different systems providing three different phone numbers, and when the call center wants to use, they do not know which one to use. So this is a very common problem that a lot of organizations face, and so they deploy a master data management kind of a solution where they try to match and merge the profiles which they think are similar to create a consolidated profile. But once that consolidation happens, now assume that all of these three profiles somehow Reltio is able to figure out that this is the same person, and all these three profiles from three different systems. I'm sorry. So all these three different profiles from these three different systems, they merge into Reltio. But now the problem is now on that same profile, we have these three different phone numbers, right? So to solve this problem, it is, I mean, just take another scenario. Now, we have these three phone numbers that we have to solve for. Maybe the CRM system says that this phone number, I only verified it. I called the customer and I verified that this phone number is active, belongs to that same customer only a few days back. The SAP might say that I'm using another phone verification service, which tells me whether the phone number is active or not. Maybe that is the best source of information. And the marketing might say that we have been connecting with this customer for a very long time, and this phone number also works. So all of these three systems, they have a way to say that okay, this might be the best phone number, but the problem then comes to us as to what is that the golden record or the most accurate number that should be consumed by all the downstream applications. So these logic, whether it was the last updated or the most recent number, which should be considered as the golden record, or the number which comes from a specific source, or the number which was the oldest. So all of these logic is called survivorship. So basically on Reltio platform, you can define survivorship strategies on every attribute to determine which value should win for a profile when the profile has data coming from multiple different sources. So this is another example, right? So, for example, we have a crosswalk. Crosswalk is a unique record in the source system, which gets loaded into Reltio. So this is a crosswalk coming from a specific source. It says that the first name is Mike, the last name is Schumacher. There's another crosswalk that says first name is Michael, the last name is S. And both of these crosswalks are correct, right? Both of them provide the correct data. But when you want to send out a mail to this person, you need to know which first name and which last name to use. And this is where survivorship helps you determine what should be the correct name. And when the value that survivorship uh, determines as the winning value, that is called the operational value. So this operational value is what you can then consume in all your downstream applications. You can send it to all the applications that interact with, or all the other products that interact with your central product. And this value then becomes the main value or the operational value across all your systems. All right, so this was like a brief overview of what survivorship is, and now let's go a bit deeper into what all different strategies, survivorship strategies that are currently supported on Reltio. We'll also look at some of the recent enhancements that we've made on the API side and the new survivorship strategy that we released in the previous release. And I'll also do a quick demo, and then we can go to question and answers. All right, so survivorship strategies, there are two types of survivorship strategies. I mean, if I have to group those strategies into broad category, the first one is data source based. So these are the strategies that are dependent on the source of the data. And the first one is last update date, also known as LUD or recency. So basically what happens is if you define the survivorship as LUD for an attribute, then the value which has the most recent update date, irrespective of the source, wins. So it does not matter which source the data is coming from, but if it is the last updated value, that is the value that becomes operational value. Then we have the source system. The source system lets you, or the survivorship strategy lets you define a, a priority order of sources. So basically, you can define a priority order of sources where you can say that Salesforce is my most preferred source, then the CRM, then Viva, or whatever different applications that you have, different products that feed data into Reltio. And then the way platform behaves is it will first try to see if there are any crosswalks coming from the most preferred source or the top priority source. If there is data coming from the top priority source, that becomes the operational value. But if that doesn't provide any data, it looks into the next in the next order or the next source in that priority order. So basically, it keeps going into the or it keeps falling back to the next priority order until it finds data coming from one of the sources. The third one is the oldest value. Oldest value is the strategy where, I mean, you can think of it as the inverse of LUD. The value which was first populated when the record was created, that is the value that survives. Then we have frequency. Frequency is the value that appears most number of times on the attribute. So in this example that we were earlier talking about, if there are 5 sources that say that the first name is Michael and only 2 that say that the first name is Mike, then most probably it makes sense to assume or to create a strategy that says that first for the first name, the value which has highest frequency that wins. So in this scenario, the frequency might make sense. So value which is occurring most number of times is the operational value. And then we have other attribute winner crosswalk. Uh, so for the other attribute winner crosswalk, what happens is sometimes the data that, or I think it will be best if I take an example. Now assume that we have phone number. Okay, so phone number, and then there's a status for the phone number, whether it is verified or not. And assume that there's also a country code for the phone number. Now, all of these 3 fields, they come from the source system together. So when a source system provides the data, it would give you the phone number, the status of the phone number, and the country code. So all of these 3 values come together. Now, what you want to do is you want the phone number which has verified status that should win. If the phone number does not have verified status, that should not win. So in this case, what you'll do is maybe on the status, you can define a survivorship strategy, say maximum. So maximum will ensure that the verified status wins. And the phone number and the country code, it should be the same value which is coming from the crosswalk that provides the verified status. So the survivorship of number and country code is dependent on the status. So in this scenario, we can use the other attribute winner crosswalk. And for this other attribute winner crosswalk, you have to define a primary attribute. This primary attribute could be status in this scenario, and the data which is coming from the same crosswalk which provides the status winner, that same data will be used for the other attributes also, phone and country code. Right. Finally, finally we have the winner entity crosswalk. So when multiple profiles merge and we get a winner profile, in that case, this survivorship strategy makes all the values from the winner as the winning values or the operational values. All right. Moving on, we have the data or value-based strategy. So these, what we discussed so far, they were source-based strategies. Now these are some of the value-based strategies. The first one is called aggregation. Aggregation basically means that all unique values on the attribute, they will all become operational value. So it also tries to, what I'm also trying to explain is that it is not necessary that that an attribute will have only one operational value. An attribute can have multiple operational values, but you can configure your survivorship rules in such a way that you fall back to having only one in case there are multiple values. I'll discuss that in more detail. But for now, aggregation allows all unique values to become operational value. This could be useful in the scenarios where, say, a customer has multiple phone numbers, a business phone number, a personal phone number, a mobile, landline, and a few other phone numbers. Now, you want all of this information to be available in the downstream applications. You do not want to restrict it to like some system might be interested in, say, official phone number. Some might say that personal phone number is better for their use case. So in this scenario, what you want to do is you want to retain all the phone numbers because probably they're all valid phone numbers, and let the downstream applications decide which number they want to use to contact the customer. So aggregation helps you achieve that use case where all values become the operational values. Next, we have the minimum value. Minimum value, in this case, basically it's comparing the values to determine which one is the minimum. If it is a numeric attribute, then the smallest value becomes the minimum value and the operational value. If it is, say, a date and timestamp, then the earliest one. And if it is a string, then the lexicographical order becomes the minimum value. And maximum value is opposite of that. If you want the maximum value to survive, then you can use the max value survivorship strategy. And the most recent one that we've added on the platform is called the value-based priority. So in some sense, it is similar to a source-based priority where you defined a list of sources from which the operational value will be picked. This one defines a list of values in the order of priority, and the value which is highest on the priority becomes the OB. So basically, for example, for a status, you have verified, unverified, unknown, or something, and you want that if verified status exists, that should only become the OB. Then you can define a value-based priority where you give the priority order of all these three values. So verified is your first priority, unverified is your second priority, and then third is unknown. So if a profile has verified from any of the sources, that would become the OB. So this helps you define a priority order of values from which the OB gets picked. Okay. Any questions so far?
So there are a couple of questions in the chat. The first one says, are these strategies preset or can we change as needed, from Sufyan?
Right. So see, every uh, for every entity and every attribute, there's a default survivorship strategy, which is recency. If you do not set anything, then recency or LUD is used as the survivorship strategy. But you can configure and you can change the survivorship strategy. You can override the default for any attribute. And I'm going to cover also a recent update that we're going to make in that. I mean, recent update or uh, new update that we're going to make in the platform to let customers also define this default strategy. Instead of LUD, you can maybe for the entire entity, you can choose source system as the default and overwrite it for specific attributes.
And then there's
Anything? Yeah,
yep,
sure.
there are two more questions. I've got you, Sarah. The second one is, can I define a survivorship strategy for relationships within an entity type?
Yes, you can define survivorship strategy for relationship attributes also.
And then the last one is, can you describe the difference between other attribute strategy versus winner attribute strategy?
Right. So this is winner entity crosswalk. So this works at the entity level. So for uh, see, here it is talking about merging when multiple profiles merge and one of the profiles becomes the winner, right? Generally, it is if you do not specifically mention which profile becomes the winner, then the profile which already exists in the system or the older profile is always the winner. So in this case, what happens is for example, in name attribute, I merged two profiles with two different names, Mike and Michael. Okay, Mike was already existing in the system. Now there's another profile which came into the system with the name first name as Michael, and these two profiles merged based on the SSN number. The SSN number was same, so platform determined that these are same profiles, and we merged these two profiles. Now the first name has both Mike and Michael. Okay, so for the winner entity crosswalk, if this is the strategy which is chosen, then the operational value might will become the operational value because it belongs to the winner entity, the entity which was already existing in the platform. So this is how winner entity crosswalk works. Whereas this other entity crosswalk, maybe let me take an example. Let me see if I act excel. All right. On that is okay, let's assume that there are these three attributes. And there's only one profile. We're not talking about any merges right now, but there's only one profile which gets data from multiple sources. And the phone number is 123. Status is verified. And this is coming from source one, source two. Source two says that the phone number is 234 and the status is unverified. Okay. And then we have country code 9191. So in this scenario, what you ideally want is first you want to see which phone number has the status as verified. And whatever phone number has the status as verified, you want that same phone number to win, correct? Because this is already verified. So it does not make sense that the status is verified, but for the phone you want 234 and the country code you want this to win. So basically the survivorship of phone and country code, it is dependent on which value wins for status. Okay. So in this scenario, what we can do is for status, maybe you can define the max survivorship strategy, max value between these two. Verified becomes max and that wins. So for the status, this value wins. And for these two, you can define other attribute winner crosswalk, other attribute winner crosswalk. And for this other attribute winner crosswalk, there's another parameter called the primary attribute. The primary attribute in this case will be status. Okay. So what platform will do is it will check for status, which is the crosswalk which is winning. For status, because this is the crosswalk that wins. For status, this is the crosswalk that wins. So that is why for phone number, it will take the same crosswalk and survive the same value, or make the same value as OV true, which comes from the crosswalk that provides verified status. Similarly, for country code, you can have the same thing. So for country code also, you can define the other attribute winner crosswalk as the strategy, and the primary strategy, the primary attribute as status. I hope that makes sense.
Saurabh, there's a couple other questions in here too. I don't know if you want to take a look at the chat and just
Okay.
like quickly pull it up and just see.
Okay. Uh,
You
Sorry,
should be able to pull up the chat without having to exit
yeah.
out.
Okay. Survivorship based on score. So survivorship based on scoring is not yet implemented. I mean, there's no score that is calculated for an attribute. But if you want to implement some custom logic, maybe you can add another attribute which calculates the score for every crosswalk, and then you can use that attribute in the other attribute winner crosswalk to update the strategy. I mean, I'm just thinking about it, but right now, yeah, we do not have scoring available for the attribute to define what survivorship strategy should be used. As we can change survivorship rules, do we maintain traceability on which order rule had updated current golden record? So yeah, so this is another enhancement that we are implementing on the API side. So for one thing to note here is that the operational value is not stored. Operational value is calculated on the fly. So whenever you are retrieving data from the platform, that is when the survivorship strategies are executed on that attribute, on every attribute, and the operational value is determined during the fetch call. So what it means is we are not persisting the operational value flag on any attribute. So what we are doing is now or we'll be releasing it soon, where we have added an additional parameter in all the get entity, get relationship, and all the APIs that return data. There's a new parameter which is being added, which is called show applied survivorship strategies. When you pass that optional parameter in the API, you'll be able to see the complete trace of survivorship strategies that have been applied on that attribute. So it is possible that first the survivorship strategy that was applied was say LUD, but LUD returned multiple results. So there was a fallback on maximum value or min value or something. So that option will help you to understand how the survivorship strategies on every attribute was applied. I think the question is, can you base a survivorship rule for a given entity based on the relationship that provided the crossword? An owner relationship providing the postal address wins over an insured relationship. Yeah, so right now, no, we do not support that relationship crosswalk being used in the primary entity. Actually, we do support survivorship for reference attributes. So if the relationship attributes are also reference attributes, it might be possible, but I think I'll have to test it out. And in fact, you can also test it out. If you add the relationship attributes as reference, then you can define survivorship on reference attributes and probably also use it in the primary attribute. Are there special considerations for survivorship rules given a golden record splits or merges? Are the survivorship rules applied when creating new golden records? So, right, while I think I answered this before, the survivorship rules or the survivorship values, operational values are not persisted in the platform. It is generated on the fly when you're retrieving the data from the platform. So doesn't matter whether the entity is split or it is merged. When you fetch data for a specific entity, that is when the survivorship value will be calculated on the fly. winner attribute strategy available now? Yes, it is available. It should be in your tenant. I think within the tenant configuration in the L3, there's a section called survivorship strategies, where you define all the survivorship strategies that you want to use. And there, if it is missing there, other attribute winner crosswalk, you can check it in your entry. But yes, it is available. It's been available for a long time. If you are unable to find it in your tenant, maybe you can create a support ticket and somebody will be able to help you with that. Okay. Could we just set a custom attribute to suppose a relationship that might work? Yeah, so this one, again, I think it might be possible depending on how complex the use case is. If you have, if you define a custom attribute that somehow, I mean, see, the only thing that I can think of is somehow using the other attribute winner crosswalk for this custom attribute logic. So if you can define your custom attribute to somehow relate to the survivorship of other attributes, maybe it is possible, but there's something that needs to be tried before actually confirming anything. All right, I'll continue. All right, let's talk about survivorship for nested attributes and reference attributes. So this is slightly different from the simple attributes because you can think of nested attributes or the reference attributes as a folder structure. So the nest itself doesn't have the data. It is a simple attribute within the nest that actually has the value, right? So whenever you're defining survivorship for the nested or reference attributes, there are few additional configurations that might be required. First, you need to define which survivorship strategy should be used for a specific nest to win. For example, we were looking at that example where data was coming, two different phone numbers. Now assume that that phone number structure was a nested structure. So in this scenario, maybe you can define, first you need to choose which survivorship should win and within, or sorry, which nest to win. So you need to define a survivorship at the nested level. And then within the nest, if there are multiple values, then which value should survive. For that, you need to also have survivorship in the sub-nested or the simple attributes level. For value-based survivorship strategies, I mean, at the nested level, if you want to use a value-based survivorship strategy, then there's another parameter that you need to be aware of, which is called comparison attribute URI. And it is because, like I explained earlier, the nest itself doesn't have a value. It is the sub-attributes within the nest that have value. So if you want to use any of the value-based survivorship strategies, you have to also define which attribute to use for that value comparison. Okay. Uh, Again, here is an example, phone, type, number, and verified on. So two different sources providing the data. Source one provides this data. And then we have another source which provides two phone numbers, both for mobile, and it was verified on. I mean, the verification is later for the source two. Now within these two, first maybe you want to determine which nest should I use. Maybe source two is better because it was verified more recently. So you can use a survivorship strategy for max value and comparison attribute URI and verified on because it's the date, the max value will be the latest one. So if you define a survivorship strategy on phone attribute with max value on verified on, then this nest wins. Then within this nest, uh, between these two phone numbers, you can choose whichever you want, whether it is the recency or based on however your or based on the quality of your data, understanding of your business, you can choose which one from these two win and arrive at a unique value. So for the nested in reference, the important thing to remember is if you're defining a survivorship at nested or at the nest of the reference attributes, and you're using value based, you need to define a comparison attribute URI because those nest or the reference group itself doesn't contain any data. So first you define at the nested level for a specific nest or a specific reference set to win. And within that, you can then define on all the simple attributes, you can define individual survivorship strategy for the individual values to win. All right. Now, let's go a little bit deeper into the survivorship strategies. Let's assume that there's a case that the primary strategy that you've defined on an attribute, it does not return a unique value. Okay. We saw that aggregation does not return a unique value. Or if you have set the survivorship strategy to say recency, and somehow two different systems are updating the data at the exact same time. Um, so there could be scenarios where the survivorship strategy would not retain a unique value, would not return a unique value, or there could also be a situation where the survivorship does not return any value at all. Okay, it could be, and for example, okay, this is another parameter that I wanted to discuss. There's a parameter called sources for OV. So this parameter determines which sources do you want to consider for OV calculation. Now assume that you're doing OV calculation for your individual entity. And for the individual entity, you're also getting data from Facebook or Instagram or somewhere. Now, the individual data on Facebook or Instagram that might not be reliable. And so you do not want to consider it at all in your OV calculation. Okay. So in this scenario, what you can do is you can define a parameter called sources for OV, and you can exclude Instagram or Facebook or any of the social network sites data from OV calculation, but you do want to maintain it in the platform. So in this scenario, you can define the sources for OV and exclude any sources that you do not want to consider. Or alternatively, you can add only those sources that you want to consider for the OV calculation. Now assume that you have sources for OV defined, and the attribute contains data only from those sources of OV which which are excluded. So in this scenario, nothing will win, right? Because all the sources that provided data for the attribute, they are excluded from OV calculation. So the attribute will not have any OV. So in this scenario, I mean, in these cases, when you have more than one values or you do not have any values, there's something called fallback that we support on the platform. So fallback, it helps you resolve the ties, or when there are no winners, it helps you resolve the situation and arrive at a value which can become OV. So fallback can be executed on two conditions. One of the conditions is called more than one, when the attribute has more than one operational value based on the primary survivorship that has been applied. And the other condition is zero or more than one. So if the attribute either has zero values or more than one value, then you can apply the fallback. Here you'll see that currently there is no zero condition, right? So to fill that gap where we do not support only zero conditions, there's another enhancement which is being planned, or which is releasing with our 25.2 release. So whenever you define a fallback, you need to define what is the condition based on which the fallback will be executed. Should it be more than one, or should it be for both zero or more than one? Once the condition is defined, then you can define the fallback strategy. So for example, I define my primary strategy as um, recency that returns 5 values. Then I can define a fallback strategy of maximum that will return just one value. So something of this sort is possible, and you can have like a whole chain of fallbacks. There's no technical limit as such, but just improves the or just enhances the complexity of the platform. So should have a considerably uh, or you should be considerate about how many fallbacks you put in the system, not add any unnecessary fallbacks. But there's no technical limit on the number of fallbacks that you can build. One thing to remember for fallback is it is only the winner crosswalks from the previous strategy that is used for calculating the OV. So let's take an example that an attribute had 8 different values. You applied the primary survivorship, uh, based on which now only 4 values are surviving. You still have four values, but four values have been discarded by the primary survivorship. Now, when you apply the first fallback, only those four values will be considered for fallback. Okay. Unless sources for OV are different. So until recently, the sources for OV, it could only be defined for the entire survivorship, or it could only be defined for the survivorship group or survivorship of individual attribute, but we could not define different sources for OV for primary and fallback. But now with the latest or announcement that we've done recently, we can have different sources for OV for primary as well as for fallback strategies. So unless you have different sources for OB for primary and fallback, only the winner crosswalks from the previous strategy goes into calculation in the next step. Okay, and like I mentioned, each fallback loop can now support different sources for OB. So this was fallback, and the other problem that we are trying to solve through the survivorship is um, uh, or to support filters. Now, assume that you want your survivorship to be dependent on the values of the attribute. For example, um, if the address is in US, you think locate provides a better quality addresses or better verification if the address is in US. So you have a crosswalk that does run the verification through locate and provides the data. Now, for addresses in India, maybe locate doesn't do such a good job, but Google Maps API does a better job. So maybe you have another source that runs India addresses through Google Maps and then loads the data into Reltio. Now, between these two, the survivorship that you ideally want is if the address is in US, then I want locate source to survive or to become the operational value. But if the address is in India, then the Google source should be higher priority. So this kind of a filter you can create in your survivorship. So you can define a filter that if the country is US, then use this survivorship. If the country is India, then use something else. But you also should be considerate about what happens when the filter conditions are not met. So assume that you define these two conditions. Country is US, use locate. Country is India, use Google. Now, what happens if country is not US or not India? In that case, it will fall back to the to default survivorship, which is LUD right now. So either if you do not want it to have a default, then also have a condition where you handle the default values or all the other values. So until recently, the filters only supported very uh, basic conditions. Equals to was supported, and there were no and or conditions also. But now we do support complex filters. It is currently not in the UI, but directly in L3 configuration, you can configure complex filters. Something like this end date is missing. So earlier there was no concept of missing exists and so on, but now you can define all of these missing or greater than now country exists. So all of these complex filter conditions are supported, and in the documentation you'll find some good examples of what are the different types of conditions which are supported and how do we configure that. All right. Before we take another question answer session or question answer break, let me just cover this final topic, which is called survivorship groups or rule sets. Uh, okay, so let's again take this example. You have different teams in the organization. The finance team says that I want the official email ID whenever I retrieve data, then the only the official email ID is required, whereas the marketing team says that for marketing purposes, personal email ID is required. So basically, these are two different organizations or two different group of users who want to have different survivorship on the same attribute. This feature is also supported and it is called survivorship groups or rule sets. So basically, you can create different survivorship rule sets or different survivorship groups and assign them to different roles. So I create one group where the official email ID survives. And for this group, I assign role A access to only this group. Then I create another survivorship group where personal email ID survives, and I assign role B access to this survivorship group. So anybody from role A, when they try to fetch the data, they will receive whatever is the survivorship group that they have access to. And user with role B will receive their specific survivorship responses. Okay. All right. Let me see if there are any further questions.
I think that was
Uh,
the just
mm,
that last question about the custom attribute was the last one that's in
mm,
the chat.
right. Okay, great. All right. So what I'll do is I'll just quickly, the survivorship. Okay. So survivorship groups can be configured in UI in console. In the console, when you go to the data modeler app and you select an entity, yeah, in the data modeler entity types, you'll see all of these different entities which are present for your tenant. You select the entity type and go to the survivorship tab. You'll see the different groups which are currently existing in your tenant. So this is the default survivorship group. And yeah, when you're defining survivorship group, at least one group has to be default. So this is the group which will be used when a user does not belong to any of those two roles that you created. So a third user who does not belong to role A or role B, if they want to fetch the data, then the default survivorship group will be used. If you want to create a new survivorship group, you just need to provide all these details, name, description, if you want it for a specific role, otherwise you can leave it blank. Then click on add attribute and then just select the attribute for which you want to add a survivorship group. Default is recency or LUD, but here you'll see all the different options that are supported. Let's take source system. So when you define source system as the survivorship strategy, as I was explaining earlier, you also need to define a priority order of the sources. So here, click on this icon, and it will give you the priority order of the sources. You can drag, drop, and decide which one to put on higher priority versus which one to not. And you can also remove any sources that you do not want to consider in this priority order. Okay. Then you can define any fallbacks. Okay, so here if you click on the fallback, it says that the primary strategy is source system. If you want to create a fallback, just click on create new and then mention what is the condition for fallback, whether it is more than one or zero or more than one. And then what is the rule for fallback? So if recency doesn't return or if recency returns zero or more than one value, then apply, say, oldest value survivorship strategy or something like that. You can keep adding more fallbacks if you want to have it in the same condition. But if you want to, change the condition, then add a nested fallback. And here you can also change the condition and define the next survivorship strategy that should be applied in the fallback scenario. Then for filters, currently the filters that are supported on the UI are very basic. Like I was saying earlier, we only supported equals to condition. So that is what is supported on the UI, but you can have more complex filters. Okay, so for filter, basically, I'll suggest that instead of using the UI, you go to advanced editor. In the advanced editor, you'll get the L3 configuration and you can define filters in the L3 configuration also. I'll open one of the existing survivorship groups. Right, so this is the complete survivorship group configuration, which is part of my L3. I can directly update here. You'll see that, I have certain fallback strategies. I probably will have some filters also. Yeah, so for example, I define this filter here, filter in condition. So all of these different conditions which are supported in filter, they're all part of the documentation. If you want to build any specific custom filters for your survivorship, you can review the documentation and configure it accordingly. Right, so once you're done creating your survivorship, done creating your survivorship groups and rules for all the attributes, We can then save, and the survivorship becomes active immediately. So basically, next get that you do, next record that you fetch, it will have the survivorship based on the survivorship that you just configured. Again, because the data is not persistent, OV values are calculated on the fly. Okay, all right. All right, let me go to some of the API enhancements that we've done recently. I would not say that they're all like very new. Some of them already existed, but I'm just covering it here again because sometimes these updates get missed in all the other cool enhancements that we keep doing. So the first one is retrieve data with a specific survivorship group. So currently, when you want to retrieve entity, when you execute the get entity, then either based on your role or the default survivorship group executes. And you'll retrieve, or the data that you'll receive will have operational values OV flagged true only for the survivorship group that was executed, either the default one or based on your role. If you want to execute a specific survivorship group, then there's an optional parameter, explicit survivorship group, and then the survivorship group URI. What this API will do is, it will return the data, but it will execute the survivorship group based on what you've mentioned here. So it does not take the default survivorship group, but it takes the specific survivorship group that is mentioned in the URI. If you want to overwrite the default survivorship group, maybe for your testing purpose, or if you want to see what will happen if I change the survivorship group from recency to frequency, then you can also use this API. So get entity with additional optional parameter called get with survivorship rules. And in the body, you can provide the exact survivorship strategy that you want to execute. So maybe in your default survivorship group, the first name may have recency as the survivorship strategy, but it will get overridden with frequency when when this API returns the data, it will override recency with frequency because we have explicitly mentioned it in the request. The new enhancement that will be releasing soon, I think, or we might have just recently released it, is called Show Applied Survivorship Rules. So this is a new option that we've added, which is called Show Applied Survivorship Rules. This would be useful in the scenarios where you want to determine how the survivorship rule was executed. So, we looked at those fallback scenarios, right? So the primary survivorship is recency, but because there were so many different fallbacks that got executed on the attribute, the actual survivorship which returned the result might be, say, frequency. So in this scenario, I mean, if a customer doesn't, or if a user doesn't know uh, that there were fallbacks that were applied, and if they want to understand how this value survived, even though they have a more recent value, then this option will be useful. When you provide this option in the response, you'll get another parameter called applied survivorship rules, and it will give you the path of different survivorship that were applied. So basically, first the source system was applied. After that, the LUD was applied, and LUD returned the final response. All right. And moving on to some of the upcoming enhancements that you'll see as part of 25.2. One is entity level default survivorships. So right now, our default survivorship is fixed. It is hard coded in the platform, and it is recency. There's no way for you to change this default survivorship. Now, assume you have an entity with 150 attributes, okay? And you want the default survivorship to be source system for all of those attributes. So now, as of now, you would have to update every attribute survivorship strategy to that source system or whatever you want, because the platform will always fall back to the default, which is recency. But after this change, you'll be able to define or you'll be able to configure a default survivorship strategy per entity. So on every entity, you'll be able to configure the default survivorship strategy, and that will be used when no other survivorship strategy is defined on the attribute. Next is zero fallback condition. So when we were talking about fallback, I explained that we have more than one and zero or more than one, but there's no zero condition. So assume that you have a scenario where you want to have different fallback for zero condition and different fallback for more than one condition. So maybe recency for zero and max value for more than one. So this kind of configuration is not supported right now because you do not have a zero exclusive zero condition. You only have zero or more than one, right? So with this enhancement, you can now also support this case where you want to have different fallback strategies for zero and more than one condition. All right, and the third enhancement that we're doing is case insensitivity of value-based strategies. So all the value-based strategies like max value, min value, value priority order, and all those things, right? Right now, the values that are considered, they are case sensitive. Now assume that I want to define a value priority order. Okay. If the value is again the value is verified, it should win. Otherwise, unverified should win. Otherwise, unknown. So I have this priority order: verified, unverified, and unknown. Now these source systems might be sending data in different cases. One source system might be sending everything in caps. There's another system sending in camel case. There's another system doing everything in small and so on. So the number of combinations of values, if it was currently it is case insensitive. So right now, sorry, currently it is case sensitive. So if you want to handle this scenario, you'll have to define all of these different values in the priority order. So you'll have to mention all caps also, all smalls also, and then camel case, any other case that you get the data in. So you'll have to maintain that list of all the different combinations of the cases. But with this enhancement, case insensitivity, there would be a flag. You can just turn on that flag and then value. We will ignore the case of the data and just consider the value itself. So I hope these three enhancements will be useful in the complex survivorship rules that you'll build. All right. I think that brings me to the end of the presentation. I see there might be a few other questions. Let's just see. One second. On an attribute, rule sets, can you set survivorship group on an attribute of an attribute in the entity example? Individual entity can be customer or an advisor. Is there a is there an indicator provides that? Okay, can we set a survivorship, different survivorship group based on the value of the so survivorship group you cannot provide based on the value. Uh, I mean, you can create two survivorship groups. All the survivorship value for all the attributes could be same. I'm sorry. I think I'm not really sure how do you or can you explain this question again? And is it Sandro? Yeah. So Sandro, basically, see what I'm trying to say is you create two different survivorship groups, right? And those survivorship groups can have their own survivorship strategies. They do not have to be dependent on each other. Now, if you create these two separate groups, you can have different roles having access to these two groups. But if you want, I think what you're trying to get to is the same role having different values based on or different operational value based on the entity type, individual entity and customer or advisor. I think you can use filter in this scenario, right?
It's this is Sandra. I think what I was trying to get at, we made a mistake on individual entity. We should have created separate entity types, but in the same entity
Okay.
type for individual, it can be a customer or an advisor. If it's an
Okay.
advisor, I would rather have a different rule set for survivorship than it is if it's a customer. For example, different source system sequence to survive values, and I'm wondering if that's possible without using roles. Can you base it on the value of an attribute in the entity that indicates whether it's a customer or an advisor?
No, the entire group cannot be based on the value of an attribute. You can have different, like for individual attributes, you can use filters to do that segregation, but not on the entire rule set.
Okay, gotcha. Thank you.
So there is no dynamic value-based rule assignment, is right?
So value-based assignment is what filters is for. So basically, but that filters works on individual attributes. You cannot have a filter for the whole group, is what I'm trying to say.
So that might work. I'm thinking of specific attributes, not the whole group.
Okay.
So I think that is possible then. Okay.
Correct. You can use the filters scenario, right? So if you recall, we were talking about it, right? Or I can actually this. Yeah. So here in the I need to refresh. But if you recall in my L3 configuration, I was showing you that I've defined filter on an specific attribute equal to a specific value, right? So these kind of filters you can build. You might be having an attribute called individual type or something. So you can use filter on that attribute and then choose what survivorship strategy to use based on the value. Yeah. Using batch will only give us the raw data. So no, that is not true. Even batch internally calls the APIs to retrieve the data. So all your batch responses also will have OB equals to true or false. So what are stored as golden records? So yeah, so see, all that we store is a consolidated profile. So what you'll see, or what we have in the database, is merge of all the profiles and crosswalks that came together to build one consolidated profile. The flags itself, well, like what is the operational value? That flag is not stored. That flag is calculated on the fly. So based on which user, which role is calling it, whether you want to use the default survivorship strategy or some other default survivorship group or some other group, based on that, the operational value flag is calculated on the fly.
Hey, Saurav, can you just explain exactly the same point a little bit in more detail?
Okay, so yeah, let me just find some data. Yeah, this is my test tenant. Maybe it would not have data with a lot of crosswalks, but it might just be enough to explain the use case. All right, so let's look at this profile, right? So this profile has data from all of these different sources. There's a Salesforce source. There's also Reltio. Somebody added the data through the UI, or when loading the data, they added it as Reltio source. Then we have a Reltio ID crosswalk, a function cleanser crosswalk. So all of these different crosswalks, they together build this profile. It's called a consolidated profile because it has data coming from multiple sources. So this consolidated crosswalk or this consolidated profile actually has data from all of these different sources. But when you fetch the data, let me just get this entity through the API also. All right, so let me call that same entity. Right. So now if you look at this profile, right, and when you get this entity, you'll see that for name, there are two values, Rudyard test, Rudyard Isaac Drake. One of them is OV true, the other one is OV false. So basically, both of these details are all the details, all the crosstalk, every information that you load into Reltio, that is still retained. But this OV flag, which one is operational value, only that is calculated when I execute this API. Or UI also executes this API in the backend to get the data. So any API that returns data for you, in that API, before the data is returned, we do the operational value calculation and then apply this flag OV true or OV false. Does that help, Sufi?
So a related question now, because some of the survivorship rules may be based on fuzzy logic, and maybe I'm not sure if you're using any Gen AI capabilities in the background. So is it possible if I fetch the same API twice, I may get slightly different answers?
So first of all,
Yeah.
unless the data is updated or the survivorship rule is updated, I don't think you should get different answers. Right now, there's no AI-based survivorship support or some
Okay.
fuzzy logic that might change.
Okay.
Right now, yeah. So as of now, unless you update the data or you update the survivorship group or the rule set, it should not change. You should get the same value.
Thanks, Saurabh.
We are at time, everybody, but if you have any further questions, you can actually, when I put this up on the website, on the community site, there is a section where you can ask further questions. And then if you ask the questions under that blog post, then we can answer them in the blog post, and it could help you guys further to, like, for more information, for instance. Or you can always put up a post on the discussion boards. That being said, Saurabh, I'm so sorry you stopped sharing, but there is a slide that I wanted to share at the very end.
Oh,
We do have a number of community shows that are coming up. That one of which is not really a community show, it's our release. So our release webinar, if you want to go just after this, yeah, there we go. Our release webinar is happening on September 22nd at 11 a.m. Eastern time. It is up on community as well as on our website and a number of different places. So if you want to register for that, I do recommend that. We have a community show on agent flow on September 30th. And then on October 15th, we'll have a community show on the new UI format. So we look forward to seeing everybody in the coming weeks. We have more stuff coming up as well. There should be another show in October as well as the one that's up already. So keep your eyes out, and we will see you next time. Thanks, everybody.
thank you. Bye.